Okay, naming. So naming binary ionic compounds, you have a cation and an anion. Positive cation is written first, it takes the name as the element. The negative anion is written last, and you change that ending to IDE. So you need to know which ions or which elements form which ions. Okay, we labeled them last year on your periodic table. All compounds have to be neutral. So if you have a Roman numeral, or I'm sorry, if you have a transition metal, you have to specify its charge with the Roman numeral. So copper bromide is written as copper 1 bromide. We know bromine always has a -1 charge. That means since we don't have any subscripts here, copper has to be +1. All right, if you want to try to name these, lithium fluoride, calcium bromide, potassium sulfide, iron 2 sulfide, because again, we have one of each, and sulfur is always a -2, so that means iron had to be a +2. Magnesium oxide, manganese 2 oxide, cobalt 3 iodide. All right, naming compounds with polyatomic ions. I'm sure there's a polyatomic ion in your chart in your book. If not, I can get you one, but you have to memorize the common polyatomic ions that you did last year because they're not given to you on the AP exam. All right, so ammonium is going to be your only polyatomic cation that you need to know. So you name it ammonium chloride or ammonium nitrate. NO3 negative is a nitrate ion. You don't change the ending of the nitrate. Cyanide, hydroxide, and peroxide are the only polyatomic ions that end in IDE. So here's kind of, I don't know, a trick to learn all the different oxo anions. So hypo, whatever element that is, ite, is going to have two less oxygens than the 8 version. Ite is going to have one less oxygen than the 8 version. So then you'll have your whatever 8 per whatever element 8 is going to have one more oxygen than the 8. So here, this is chlorate. So hypochlorite, see, it has 2 less oxygens than chlorate. Chlorite has 1 less oxygen to the 2. That's chlorate. Perchlorate has 1 extra. Okay, sulfate and sulfite. Sulfite has 1 less oxygen. There's no hyposulfite or persulfate. Okay, so let's name some of these. Copper 2 carbonate, potassium sulfite, calcium hypochlorite, potassium perchlorate, sodium chlorate, lithium nitrite, sodium acetate. Sometimes you'll see acetate written as C2H3O2, and it's the same thing. So recognizing ionic compounds, you have to have a metal and a nonmetal or some sort of polyatomic ion. Writing ionic formulas. So again, all ionic compounds have to be neutral. The charges come from your periodic table, and make sure you use parentheses if you have a multiple of that element or ion. So calcium chloride, calcium has a +2 charge, chlorine has a -1 charge. So you do your crisscross method. This 2, you're going to bring down here. This 1, you bring down here, but you don't have to write the 1 like in algebra. Okay? Iron 3 sulfite, this 3 tells you the charge of iron, it's +3. Sulfate has a -2 charge because you memorized your list of polyatomic ions. So again, you do the crisscross method, and make sure you always use parentheses around your polyatomic ions. Okay, so let's try these. Pause the video, write them, and check your answers. Okay, so recognizing binary covalent compounds, they're going to be made up of 2 nonmetals. Here are your list of prefixes, and remember you don't use the prefix mono on the first element, and always change the second element to IDE at the end. Okay, so name these, pause the video, check your answers. silicon dioxide, carbon monoxide, carbon tetrafluoride, tetranitrogen tetraoxide, xenon hexafluoride, dinitrogen trioxide, tetraphosphorus heptoxide. Okay, so let's write them. You just, whatever the prefix says, that's how many you have. 1 carbon, 2 oxygen, 1 phosphorus, 3 chlorine. Okay, and so on and so forth. All right, acids. So usually acids start with H. Hydrogen's always your cation. For organic acids like acetic acid, your H is at the end. Okay, so there's 2 types of acids that we'll look at, ones that have oxygen and ones that don't. If they have oxygen in them, the oxacids, you're going to change ate to ick or ite to us and add acids. So this is perchlorate ion, ate becomes ick, so this is perchloric acid. This is the sulfate ion, so ate becomes ick, sulfuric acid. This is acetate, so acetic acid. This is ion is sulfite, ite becomes sulfurous acid. This is nitrite, ite becomes nitrous. Okay, if you don't have an oxygen, then you add hydro, whatever the element is, change ide to ick, and then add acid. So this is cyanide ion, ide, hydrocyanic acid. Chlorine, hydrochloric acid. Bromine, hydrobromic acid. All right, so name these pause videos, check your answer. Ta-da! Hydrates. So this one is new. We didn't name hydrates in pre-AP. They're just ionic compounds that have trapped water within their structures. So you did this with the lab. Both the name and the chemical formula specify how much water is in the structure. Okay. So you'll still write your ionic compound that you always did, and then you'll just multiply by however many hydrates you have, and you use the prefixes that we do for the covalent compounds. So sodium sulfate decahydrate, sodium sulfate regular, times 10 waters. That means water. Okay. So barium chloride dihydrate, right? Barium chloride. This tells you have 2 waters attached. Iron 3 chloride, 6 waters attached. Iron 3 chloride hexahydrate. All right, try these homework problems and we'll talk about them in class.